Hi students, welcome to today's lecture. This is the second lecture of the lesson describing motion. In the previous class, we were discussing about few topics of this lesson. Krishnali, you are giving me a smile. I think you are remembering all the terms. Yes or no? Yes. So you please tell me which are the terms we have learned. Yes. What is meant by motion? What is meant by the state of rest? Which are the physical quantities and which are the two types of physical quantities. Ronak, can you tell me which are the two types of physical quantities? Yes, scalar quantities and vector quantities. Now, Mayank, can you tell me what are the differences between these scalar quantities and vector quantities? Yes. Scalar quantities are the quantities which require only magnitude to describe it, while vector quantities are the quantities which require both magnitude and direction in order to describe it. So, all of you have done your homework very well. What we will do? We will move to the next topic. What is our next topic? That is distance travelled. It's a very common thing for you. Yes or no? You all know what do you mean by distance travelled. Hemali, please tell me what is the distance between your house and St. Mary's School? Yes, 3 kilometers. Now, when she says that the distance between her house and St. Mary's School is 3 kilometers, that means that is the length of the route she has travelled during her journey. So, what is the meaning of distance? Distance travelled by a body is equal to the actual length of the path covered by an object during its motion. Now, to understand this, I will tell you an example. Take your book, lift it in your left palm. Keep your pen like this at this point, okay? Have you done? Yes. Now, together with me, you move this object like this, bring it up to here. So, what is the distance covered by this object now? That is length of this path which it covered. Yes or no? Yes. So, what is the distance travelled by the object? The actual length of the path covered by the object during its motion. Now you listen, first my object was here and it came up to this point. I have followed this path, yes or no? I could have done this way also. From here I could have taken the object this way. This is another route. If I had selected this particular route, the distance travelled by this object is different. So, what do you understand by this? Distance travelled by an object is totally depending upon the path which we have selected. Therefore, the actual length of the path covered by the object during its motion, that is called the distance travelled. Now, in this case, you please see an object is at A. It moved to B and then to C. So, it has used the path ABC. Therefore, what is the path length? 3 meter plus 4 meter, that is equal to 7 meter. Suppose he might have used this path. What would have been the distance travelled? Can you calculate? Yes, because it is a right angled triangle. In this right angled triangle, height is equal to 3 meter. Base equal to 4 meter. So, this AC becomes what? Hypotenuse. What will be now this hypotenuse AC? Use Pythagoras theorem, under root 3 square plus 4 square. What you will get? Under root 3 squared is 9, 4 squared is 16. So, under root 9 plus 16 is equal to root of 25. What is root of 25? 5. So, what will be AC? 5 meter. So, you understood? First case, if you have followed ABC path, distance travelled is equal to 3 plus 4, 7. If you have followed the path AC directly, distance travelled is equal to only 5 meter. Now, can the distance travelled by the body be 0? Is it possible? No, it is not possible. Why? If the distance travelled by the body is equal to 0, that means the object has not moved. Similarly, can the distance travelled by the object be minus, that is negative at any time? No, it is not possible. So, distance travelled by an object can only be positive. It can never be 0 and it can never be negative. So, is it clear this topic? Distance travelled. Then we move to the next topic. What is that? Displacement. Have you heard about this point? Displacement. Yes. Some similarities between displacement and distance you feel. Let us see what is the difference. Same way we will do the activity. Take your object from, keep it here, start moving it from here and then reach it here. Now, in displacement, two things you have to remember. What is the first thing? What was the initial position of this object? Where was the initial position? This corner. And which is the final position of this object? We do not have to remember which is the path it has covered. We have to remember what? Which was its initial position, which is its final position now. Then what we have to do? Join the initial position and the final position with a straight line. Then the length of this straight line gives us the displacement of the body. So, how we will define displacement? Displacement of a body is defined as the shortest distance between the initial position and final position of the body. So, is it clear to you? Yes? So, here you see an example is given, same like a right angled triangle. Object is at A, it is moving to B and then to C. But what we have to think, which is the initial position A, which is the final position C. Therefore, what is the shortest distance? I have to join A and C. So, just like the previous case, this is a right angled triangle, base equal to 3 meter, height is equal to 4 meter. Therefore, this AC equal to 5 meter. So, what is the displacement? Displacement is equal to 5 meter. Now, if we come to another path, what is the shape of this path? It is a circle. Suppose a body is here at this point and the body is moving like this along this circular path, comes to the same point. Can you tell me what is the displacement of this body? Some idea you will have. See, I will tell you again, the person was standing here. He travelled from here like this, he moved and he came back to his initial point. So, what is the displacement of the body? That is equal to 0. Why? Initial position is here itself and his final position is again here itself. Therefore, final position minus initial position is equal to 0. Is it clear? Now, suppose that the person has moved from this point and he came up to this point. That is a semicircular path of radius 7 centimeter he has moved. How will I calculate now the displacement? What I have to remember? What was his initial position? I put the mark here. What is his final position? Here. Then what should I do? Join this. You know, when I join, what I will get? The diameter of this circle. What will be the diameter of this circle? Radius is 7. So, what is the diameter? 2r, that is 2 into 7, 14 centimeter. Is it clear? Yes. Now, coming to displacement, what type of physical quantity is it? Is it a scalar quantity or a vector quantity? It is a vector quantity. Why? It has got both magnitude as well as direction. Now, coming to this displacement, in which unit we are measuring? The same like distance. So, what is the SI unit of displacement? Meter. And what is its higher unit? Kilometer. Smaller units are centimeter, millimeter, etc. Now, the question is, can the displacement of a body be 0 or can it be negative? Yes, one thing we have seen that in case of the circular path, when the person completes one full circle or one round, what is his displacement? His displacement is equal to 0. So, we can say that displacement of a body can be 0. Now, next doubt is, can the displacement of a body be negative? Yes or no? Yes, sometimes it can be negative. How will we find out? Come to this all of you are too much familiar with. What is here? It is a number line. You can see that 0 to 10 here and 0 to minus 10 this side. Now, suppose Ronak is standing at A. What is his position? 0. He is first moving from A position to B position. So, what is his displacement? Final position is 10, initial position is 0. So, 10 minus 0 equal to 10. Now, imagine that Ronak has moved from A, came to B, took a U-turn and came to the point C. Now, what is the displacement of Ronak? Just understand one more time. Ronak is standing at A and he is coming to B, taking a U-turn, comes back to C. So, what is his initial position? A. What is his final position? C. What is the difference between this initial position and final position? That is 6 minus 0 equal to 6. Again, if Ronak is standing at A, coming to B, taking a U-turn, comes to D. What is the displacement of Ronak? What you have to see? What is his initial position? A. What is his final position? D. So, now take the difference. What is D representing? Minus 4. What is A representing? 0. So, what is the difference between these two? Minus 4 minus 0 equal to minus 4. So, what happened? Displacement of Ronak became minus 4. So, what this minus indicates? Now, minus sign indicates that in this direction. So, that is displacement is becoming a vector quantity. Therefore, displacement of a body can be positive, can be 0 and even it can be negative. Is it clear? Now, next is difference between distance and displacement. I hope that you understood this. Next we will come to the topic, that is uniform and non-uniform motion. Coming to uniform, all of you know what is the meaning of uniform. What is it? Same. Yes, coming to motion also the same thing, same. Here what is the meaning? If a body covers equal distances in equal intervals of time, we say that the body is in uniform motion. Can you think about the motion of such a body? Yes, something is near to you. Can you find out such a thing in your own room? Yes, you look at the clock or you look at your watch. The hands of the clock or the hands of the watch, equal distances are covered by the hands of the clock in equal intervals of time. Normal life, is it possible for you? If you are riding your cycle from the school gate till the Gujarati medium school, are you able to ride your cycle equal distances? If I divide it into 25 meters like that, are you able to ride your bicycle every 25 meters in 5 seconds time? No, it is not possible. So, practically when we are saying this sort of uniform motion is very difficult in our daily life, but there are certain motion in which the motion is uniform. If we draw the distance time graph of uniform motion, that is distance is taken along the y axis, time is taken along the x axis, and we are marking the points. So, what is the shape of this graph I got? It is a straight line. So, what is that? For every uniform motion, the distance time graph will be a straight line. Is it clear what is uniform motion? Now, we will see what about non-uniform motion. From the word itself, it is clear what is non-uniform motion. That is, the body is not covering equal distances in equal intervals of time. Then the motion is said to be non-uniform motion. The distance time graph for non-uniform motion is a curved line. It can be a curve or even it can be zigzag. So, today we have seen 4 terms, that is distance, displacement, uniform motion and non-uniform motion. I hope you understood it. The remaining part we will continue in the next class. Thank you.